And now moving on to the next speaker, actually few speakers. We have two co-authors, Alexey Vasilev, the head of data research at Sber, and also Alexey Natekin, the general manager, Dr. Souls, the founder of Open Data Science.
Alexey will speak about open benchmark for recommendation system OpenRecSys, and colleagues, the floor is yours. Hi everyone, my name is Vasilev Alexey. I'm head of the group of recommendation system of the lab from Sberbank. My name is Alexey Natekin. I'm from ODS. So today we're going to speak about many useful things about recommendation systems and how to use them in your in-house conditions. So what are the problems that we might face when a developer wants to create a recommendation system? So first is to select a task, session-based, explicit, or something else. So first you need to understand what recommendations you want to make and whether your task is about recommendations or not. And when selecting an algorithm, it is important to know what data you plan to use, whether you take data, raw data as it is, and pre-process them and just skip some of the values. And then you need to split the data for train test. And here we might face a lot of challenges, since in OpenRecSys we have a lot of strategies. You can go with data randomly, or take them globally in timing, or split them randomly for each user, or by timing for every user. And there are also other strategies, and the challenge of making a choice here is quite relevant. After you split the data and you want to compare algorithms, you need to select a strategy of validation. What items will go into the test? All items, this is a more frequent option, or those that are already there. I mean, when you predict, you can predict both scores for all items or just for part of them. It might be items that are already in the test, or all items. Another important question is what metrics to use. In OpenRecSys, there are a lot of metrics depending on the tasks of classification and regression, and there is no one metrics that might be taken as the most important one. In OpenRecSys, there are metrics in charge of diversity, comparing against metrics for quality. And also, in the metrics, there is another problem. Even if you select metrics or one metric, then you should understand how to effectively calculate this metrics. For various metrics, there are various formulas. Various researchers sometimes understand the same metrics in different ways, and that's a challenge indeed. Another aspect, whether the algorithm you select is applicable or not for this case. Your algorithm might work effectively for small data. If your data is big, then this algorithm might not work effectively. And as of now, in order to compare various algorithms and select the best one for your task, there are various instruments around, like Replay. For instance, this instrument was developed by our lab. We are going to give you more on this a bit later. And among the instruments, you can choose any and use any instrument. And in them, you can see modules that can tackle the tasks articulated before, but all these instruments can also differ one from the other, for instance, in how you calculate your metrics. And what is the problem for ordinary developers or those who create new algorithms? There are no benchmarks today where you can compare your result against the results of other algorithms, or somehow explain your algorithm. There is a website that is quite similar to online benchmark, but here you can input any values of metrics, and they are not checked now in any way. And as for algorithms, They calculate one type of metrics, for others other types of metrics. And when you go to this page, you can see that practically it is impossible to compare algorithms between themselves. So usually we expect to see something that is shown in the left part when the loss is going down, but actually we are having, for a number of data sets, we are having various algorithms that are calculated in different metrics that do not coincide. In RecSys, over the recent couple of years, the cornerstone is reproducibility. This year, we apply for RecSys 21 conference with an article. Metrics that are called the same can be calculated in different ways. And also, we show a couple of other articles here saying that various algorithms with greenhouse conditions can show better results than if they are tested honestly. And we need to do something with this problem. And also, we will have a look at a video of our colleagues, developers of another instrument I mentioned before. Elliot, yes, please, our video.
Hello, everyone. We are Vito Valteranelli and Claudio Pomo from Politecnico di Bari in Italy. We are the main authors of an increasingly popular recommendation framework named Elliot. And today we will focus on the importance and the need for an online recommendation benchmark. Recently, recommender systems have witnessed great prosperity in both academia and industry. They have shown to be an effective way to alleviate the overchoice problem and provide accurate and tailored recommendations. Thanks to their high performance and accuracy, they have been applied in several domains, such as e-commerce, multimedia broadcasting, and point of interest. However, the impressive number of proposed recommendation algorithms, splitting strategies, evaluation protocols, metrics, and tasks led to two major concerns: unreproducible evaluation and unfair comparison. In the work by Ferrari da Crema, the authors deeply investigated this aspect and showed that there are several methodological issues related to the recommender evaluation. Indeed, not reporting a detailed description of the dataset per processing and splitting, the candidate item generation procedure, the performance measurement, statistical testing details leads to unreproducible results. Moreover, not properly selecting and tuning the baselines propagates the adoption of weak baselines. For these reasons, Bayoye and Said, in their 2021 methods work about reproducibility, pose some guidelines and best practices to address these issues. These evaluation guidelines impose a big effort for the researchers to create proper evaluation benchmarks. To address such research needs, we have decided to develop a comprehensive recommendation system framework to perform reproducible experimental pipelines, hyperparameter optimization, and evaluation procedures. Elliot simplifies the process of integrating splitting methods, hyperparameter model optimization, model training, and the generation of experimental results reports. The framework loads, filters, and splits the data considering 13 different splitting methods and 8 filtering approaches, from temporal training test splitting to nested key-fold cross-validation. Elliot lets us optimize hyperparameters using 51 different strategies and 57 recommendation algorithms, selects the best models, compares them with the baselines, providing intra-model statistics, computes 36 metrics spanning from accuracy to beyond accuracy ones, bias, fairness, and conducts statistical analysis using Wilcoxon and students' pair t-test.
However, there are different frameworks for evaluating recommender systems. Each of these may adopt different strategies for managing the pipeline. There are different approaches to consider when splitting the dataset, when selecting candidate items to be ranked, or even in the exploration phase of hyperparameters. there might be different solutions. Despite the fact that one may obtain results on the same order of magnitude, one will never obtain completely reproducible performance. Comparing these results by entering a new metric or new method will require rerunning the entire pipeline. It is well known that the introduction of quantitative benchmarks have led to the considerable performance boost in different research fields like computer vision. To ensure continuous progress, different communities focus on providing such benchmarks on the web, which enable the research area to add the new results as they arise. This allows people from academia and industry to keep track, analyze, and compare recently proposed work in these areas. The annual challenge organized by the OpenRecSys community goes in this direction, encouraging the community to experiment with new solutions to bring out new results and encouraging more researchers to get involved. There are three key factors for a successful benchmarking system: a challenging, high-quality ground truth dataset, an online evaluation repository that is dynamically updated with new results, perceptually motivated error function. A significant advantage of this kind of solution is that can be dynamically updated with novel dataset or error measures if needed in the future. Providing a standard interface to researchers, they can fairly compare new results or refresh old experiment with new solutions, such as new data, new models, new evaluation strategies.
Спасибо, Вито и Клаудио.
Thank you very much, Victor and Claudio. As we see, this problem is quite widely spread in the community. That's why today we decided to show you a new and the first in the world online RecSys benchmark. Alexey, could you please give us more? What is this benchmark all about? Okay, thank you very much, Losha. Let me tell you about more about our first benchmark, RecSys. So it is shown as a competition, container competition, in order to resolve the tasks of reproducibility. So you can download your libraries into it, and also this is an interface academicians and practitioners from the industry got used to. This benchmark is looking similar to that of AutoML solutions. So you send your end-to-end solution, and it is perceived as a completely independent on the capacities of our joint team. So it has leaderboards, technical, small check for debugging your solutions. There is a live leaderboard where anytime you can send your solution, and getting into the queue, it will be processed. But the official leaderboard of the benchmark, where we will have a lot of participants and a lot of lines, we hope so, I'll give you more on this, is complete run across all data sets. This is a large leaderboard, and it is launched by our schedule, usually once a month. As for tasks, the task is a classic one for recommendation system. Implicit recommendations only on metrics of interactions without any additional features, and you need to tackle a classic task item to user. So first launch of the benchmark, we have quite well-known data sets from this classic item to user tasks, and the most interesting thing is how these solutions will be checked. So as Losha said, and also colleagues from Italy mentioned this, for benchmarks you need a lot of things. You should not focus on on one thing. Metrics can be more focused on academic rivals, on various characters and commas, or things like surprisal or coverage. We calculate all these metrics for various cases, for various recommendations from 5 to 20, and we calculate the time to create these recommendations. How the protocol looks like. For your solutions, end-to-end solutions, Train and test set are available. On train, you prepare your model, and in test, you predict. And we are predicting only the new items. And both train and test are a bit cleaned up. For instance, in the test, there are users with not less than 5 interactions. You can read more on how the data was prepared on our site on the benchmark page. And another important point to know is that train test splits is in correlation 80 against 20. And if there are timestamps in the task, then train test split is going in timing or randomized by user item. As for limitations, recommendation system is a very consuming thing, and this task requires much capacities. And now for these solutions, we offer such machines with 96 GB memory and 12 vCPU. For solutions, we give from 1 to 8 hours per data set. That's important. And bringing it all together, we can have a large amount of digits on leaderboard. For each data set, they calculate all metrics for all cases. If your solution goes down due to a reason, it might have a bug, or it doesn't work in time, or something else goes wrong, then for this data set, this solution will have 0 across all metrics. In other case, if everything works fine, you will have a lot of figures. And then what do we have in preliminary results? Because benchmarks are launched just these weeks. As you might know, to compare and check the solutions in recommendation system is very challenging. These are the charts for one data set, ML 20 million. And here you can see that across various metrics and various solutions, the better ones are those with a different case. You can imagine what happened in the academic part of the recommendation systems. Some report that they have the best result in this matrix in this case. Others fixing their algorithm, they offer the best solution, but in a different case. But others work in a different matrix, and they say that their algorithm is the best for this particular matrix. And so we have an opportunity here to honestly compare one against the other and analyze it comprehensively. We have a lot of tasks, and we can compare these metrics. So the benchmark is different from competitions because there is no one winners. There are a lot of trade-offs and many overviews, depending on what is the most important thing for you in your specific case with recommendation. Apart from that, recommendation systems, when we're speaking about in what world we are living in, academic or industrial one, also are very different in terms of timing and resources that are needed to structure such recommendation systems. So this is just a small snippet of the difference in scales. Some models of libraries and approaches work faster, sometimes not lagging behind in terms of mathematics. Some work slowly, but in some situations that might also be good in other metrics. And in order to sort this out and have all these results at your fingertips, we need the results for you to compare things and see what happens with recommendation system now. So drawing the results, preliminary results, what benchmark is all about, we can say it again, that recommendation systems are not as simple as they might seem. These are very useful tasks, very useful solutions, but it's hard to compare them. And there are a lot of areas where you can compare them one against the other, and the situation is getting even more challenging, knowing that here we see various schools of thought from various worlds. In the academia, for articles, you need the figures in your metrics where you are better than others. In the industry, it is more important for you to whether you launch this tool or not. If yes, then how quickly it was launched and how robust and reliable it is to launch it in the industry. And for this, before this, we didn't have any other benchmark for recommendation systems, so we are offering it now. Comparing benchmarks and recommendation systems is also a challenge, and you need much resources for this task, but we also need to prepare a full-fledged design for the whole protocol in order for it to be scaled up and enhanced and discussed both in the academia and the industrial community. And all of this should be replicatable, and these results should also be trustworthy. So what can we say now? The first online benchmark for recommendation systems is now available for everyone, and we need your solutions, your instruments, and by the way, your datasets, because the more datasets we have, the better we will be in, and the better and more efficient we will be in drawing the results and looking at what recommendation systems are all about today. According to our roadmap, we have a lot of other interesting plans to execute. In the coming future, we will be able to look deeper into the figures of this first run with much electricity consumed and flops that were spent for these figures, and we plan to also increase the number of data sets and the number of groups of data sets.
And also, probably some other protocols, since certainly we can run RecSys and other tools throughout very big hardware, but we can be more realistic in the settings, which we'll try to provide later. Please join our benchmarking, join us, send us your solutions, and also if you have some great industrial datasets, your datasets will be quite happy to structure them into our general recommendation benchmark systems. Thank you. Thank you very much. Frankly, great system, hoping it will become a golden standard for everyone ultimately. Also, very happy to welcome you here. As far as I remember, this was the only presentation at the largest conference on RecSys in Russia. That's why it's great that we did that. The team from Russia did that, coming forward with this project. And we have a question regarding further development and integration with other algorithms, in particular with online recommendations. And perhaps you do have some plans on integrating with the bandits that Dmitry Bugachenko had mentioned earlier. Could you please tell us more? Yes, thank you for the question. Certainly, Alexey and the team, they are great. Well done, guys. They had raised important subjects of reproducibility and the assessment approach to the metrics. The golden standard should be how to approach the assessment. As you are aware, there are multiple approaches. However, we need to focus on standards and benchmarking. Speaking of bandits, this is quite interesting. They're quite useful. They provide real profit to those using them. However, everything is quite more complicated with the bandits. Similar to previous speakers, Alexander also mentioned RL, and RL also uses different simulators, OpenAIJ type, that we could try and craft a medium which could compare different algorithms and benchmark them against each other. Certainly it's a refined environment with refined data, with taste approaching natural. But speaking of bandits and benchmarking is still an issue of design and coming up with something new. Apart from that, we'd love to progress and go further. Now we'd like to finalize the classic tasks, because the house order needs to be maintained, all the dirty laundry and dusting needs to be done, and only then we will move on to something more actual and breakthrough, more timely and breakthrough solutions. But I think we will get to the bandits at certain point. Once again, we'd like to welcome everyone to take part in the benchmarking, send your algorithms, send your data sets, because of course certainly we cannot achieve any benchmarking without a large quantity of data sets. Thank you very much. Yes, certainly it's great that you're into this.